All right, this next lesson will be focusing on factoring trinomials and what that has to do with a graph. So you can see that this is a quadratic trinomial, and the reason I know it's quadratic is because it has an x squared term in it. What that means is that when I graph this function, it should create a parabola. Okay, in fact, I know this is a parabola that opens up because the number that's in front of your x squared term, or your a, would be positive. So this is a trinomial because it has three terms. It's a quadratic trinomial because it has an x squared in it. All right? And so what we want to do is we want to factor and solve this. If you remember correctly, when you have trinomials, you'll factor them by undoing the FOIL like this. Your two fronts have to multiply together to make your front. So to get x squared, I would do x and x. Your two backs have to multiply together to make 30. So you have a choice here. You could do 1 and 10, or sorry, 1 and 30, 3 and 10, 2 and 15, or 6 and 5. And hopefully I don't have to review this too much, but you will do 6 and 5 here. If this is a plus at the end, you'll either need to have a positive positive or negative negative. Hint, 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 hint. Since that's positive, it will be a positive positive. So now you have this equal to 0. Basically 0 times anything is 0. So if this quantity is 0, it doesn't matter what's in a second parentheses, it will end up being 0 also. So I'm going to figure out what would have to make that quantity be 0 by setting x plus 6 equal to 0. And then I will subtract 6, and x would be negative 6. So that's one solution to this. As long as x is negative 6, if you plug it back in, I would get a 0 there. And same thing goes if the other parentheses is a 0. I can subtract 5, and x would be negative 5 here. Okay, so that gives us some information about the graph, and I know you've done this before, but we'll peek at the graph of this function now. Here's the function x squared plus 11x plus 30. This is what it looks like, and some magic spots are happening according to the graph and the equation. Hopefully you can see here that it crosses the x-axis at negative 5 and it crosses the x-axis at negative 6. So when you're solving for a parabola, that's what you're figuring out, is where the graph crosses the x-axis. Okay, here's another one that's just a little bit trickier to factor, but we'll factor it like this. Again, I know it's a parabola. I know it opens up because my a term is positive. So I will factor it by making sure my fronts multiply together to make my front. So I get 5x squared by doing 5x and x. I have no other choice. For 6, however, I could do 1 and 6 or 2 and 3. And you can play with it a little bit. I will tell you that it's 2 and 3. All right. If it's a minus at the end, you need to have one of each sign. So I know I need to have a positive and a negative. Now if I check my outsides, I'm at negative 15x, and if I check my insides, I'm at positive 2x. And negative 15 plus 2 does give me that negative 13 that I need in the middle. So now I will set each of these parentheses equal to 0, and I'll solve them. So here I would subtract 2 so that I have 5x equals negative 2. Divide by 5. And x would be negative 2/5. And then here add 3, and x would be 3. So what that tells me about my graph, one more time, are the spots where that parabola, and I know this is a parabola because it has an x squared term in it, so it's a quadratic function, and it gives me the two spots where that parabola crosses the x-axis. And you can see that it's justified here with a graph. It does cross at 3, and it does cross at negative 2/5. Okay, so we'll factor a couple more and look at some special cases here. Here I don't have this set equal to 0, so I need it set equal to 0 first. I will subtract this 16x to the other side so that it's set equal to 0. I do want to list my terms in descending order of my exponents, so I would list my x squared term first, and then the term that has an x to the first in it, and then my constant, which is technically x to the 0. Okay, again, this is a quadratic because it has an x squared term in it. This is a trinomial because it has 3 terms in it, and I will go ahead and factor this. So my fronts have to multiply together to make x squared. My backs have to multiply together to make 64. So now I have a whole bunch of choices. I could do 1 and 64, I could do 2 and 32, I could do 4 and 16, I could do 8 and 8. I will tell you that this is an 8 and an 8, okay? If it's a positive at the end, it either needs to be plus plus or minus minus. Hint, 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 it's negative, so it's going to be negative, negative. Notice that I have the same thing in both parentheses, so when I go to solve this one, I will get x equals 8, and when I go to solve this one, I get x equals 8. We typically don't list it twice. What we do instead is we say this. Since it's listed twice, we say x equals 8, and then we write double root behind it. If you want to abbreviate that as dr, that's totally fine. I know what that means, but it means that you have x equals 8 double root. And let me show you how that looks for the graph. When it's a double root, what that means is that the vertex of the graph is the spot where it crosses the x-axis. So it only crosses in one spot, which happens to be the vertex, is what touches the axis, okay? So x equals 8 there is a double root. All right, a couple more here. This one is unique because I need to factor this all to one side here and move that 5x to the other side. Notice it doesn't have 3 terms in here. So I have 6x squared plus 5x equals 0. It does not have 3 terms, so it only has 2 terms. So this is a binomial. It still is a quadratic though because it has an x squared term in it, which means it's going to make a parabola. And in this case, since that number that's in front of your x squared term, the 6, is positive, it will be a parabola that opens up. I can't factor this by undoing the FOIL because I only have 2 terms to it, but I can pull out a GCF. So this has a GCF for greatest common factor of x. When I factor that out of the parentheses, x times 6x gives me 6x squared, and x times a positive 5 gives me positive 5x. Okay, now I will set each part equal to 0. Here's one part, x equals 0. X could be 0, that's one solution. And then I will set this part, 6x plus 5, equal to 0. I think you can see that you're going to subtract 5 and divide by 6, and x will turn into be negative 5/6. So although it didn't look like it from the beginning, it does have 2 spots where it crosses the x-axis, one at 0 and one at negative 5/6, which you can see is confirmed here by our graph. Okay? All right, this one also, it is a trinomial, but I do want you to know that it is not a quadratic, so the graph will not be a parabola. It has an x cubed term in it, and so it's not going to be a parabola, but we can see where it crosses the x-axis in the same format. So this one does have a GCF in it, which I will pull out, and that GCF is x. And then x times x squared gives me x cubed, and x times 12x gives me 12x squared, and x times 32 gives me 32x. And then that trinomial there can be factored again. So I will have an x and an x. And then 32 could be 1 and 32. It could be 2 and 16. It could be 4 and 8. And I will tell you that this one will be 4 and 8. Okay, if it's a plus in the back, then it either needs to be plus, plus, or minus, minus. Hint, 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 plus, plus. And again, once you've got it factored, you'll set each part equal to 0. So x equals 0, x plus 4 equals 0, which means x is negative 4. Okay. And then x plus 8 equals 0, which means if I subtract 8, x would be negative 8. So what this means is this graph crosses the axis in 3 spots. And I'll just show you what this graph looks like, and it kind of ran off our screen. It actually, if you saw it, would actually go like this, just so you know. But it does cross in 3 spots, which are the 3 spots we just solved for. All right, and then lastly, this is a binomial because it only has 2 terms in it. However, it is a quadratic because it has an x squared in it. Which means it will make a parabola, and it will open up in this case because the 1 that's in front of the x squared is positive. So this is a perfect squares way to factor. If you need to put a 0x in here, to remember how to factor this, you can. Some of you will just realize it's a perfect square and you can factor it without putting that 0x in there, and that's great. But my fronts have to multiply together to make my front, so x times x makes x squared. My backs will multiply to make 16, which means it could be 1 and 16, it could be 2 and 8, it could be 4 and 4. So I am going to make this be 4 and 4. If it's a minus at the end, you need to have one of each sign. And now if you check your outsides, which is negative 4x, and your insides, which is positive 4x, you will get 0x in the middle. So I can now set each part. So this part right here, x plus 4 equals 0. If I subtract 4, x would be negative 4. And here, x minus 4 equals 0. And if I add 4, x will be 4. Okay, so again, I know that I have a parabola, I know it opens up, and I know it crosses the x-axis at both negative 4 and 4. And this is what that would look like. Okay, so there we go.